Okay, so we're going to go over this week's Chapter 23 practice quiz. You should have a few things. At a minimum, you will need notes. Okay, there's a number of things you need to remember here, but I'd recommend having these things open. Particularly, you will need a 2-sample t-test DF calculator. This thing right here will literally give you about everything that you need on this website here. I'm going to go ahead and close it down and go back from the beginning. The 2-sample t-test calculator is really what you're going to need. Okay, everything else here is helpful, but I found this calculator to be the most helpful. Okay. All right, so looking at this quiz, and you can assume your quiz will be very similar, okay? This one says, a teacher wants to see if 2 different forms of an exam are equivalent or if one of the exams is more difficult than the other. A selection of the results are in the table below. Do these scores provide convincing statistical evidence that there's a difference in the difficulty of the 2 exams? Okay, so you have test A and test B. The teacher wants to know, based on doing, calculating statistics for this, if it's convincing that one test might be easier or tougher, right, than the other. They're not asking if it's tougher or easier. They're just saying a straight difference. Okay, when they say a difference, they don't mean less than, they don't mean greater than, they mean either less than or greater than, that we call not equal to. Okay, so our null hypothesis will be if we were to subtract test A, or the average from test A, minus the average from test B, there should be 0 difference. Okay, what we're trying to test for is if we were to subtract those, they would be different. Okay, not equal to. So we need to calculate the average from our sample for test A and the average from our sample of test B. We also need our standard deviations, okay, of A and our standard deviation of B as well. It shouldn't be too bad to find the sample size, okay? And then we can do the difference. Then we're going to find the standard error of the difference. And then what else do we got to do? Once we have all that information, we should be able to calculate. We'll need our degrees of freedom. Okay. Remember, there's 2 groups here. Okay, so the degrees of freedom is not just going to be sample size minus 1. There's a special formula we're going to use, or calculator. We'll have those details for us. What else will we need? We'll need to calculate our t-score. And then we will then have to find the probability of getting a t-score that's not equal to whatever we get there. Okay, so and whatever this is will, so all these kind of steps will tell us this answer here, probability. Okay, that probability, if it's a very small chance, right, less than 5%, less than 0.05, that we will then reject the null hypothesis. If it is greater than 0.05, then we'll fail to reject it. Okay. All right. So what we're going to do is go to our usable stats website. Okay. And we're going to calculate all this stuff instead of doing it by hand. Usually in a classroom, we would do this on the calculators, type it all in, calculate it, boom, we're good. This time, though, what you'll notice is there's 2 types of data you can type in, either the mean, standard deviation, and N. We can do this by hand. We're going to choose not to because it's just going to take too much time, and we want better numbers, okay? We want to make sure we're not rounding and doing things like that. So I'm going to enter the raw data. And right here it says sample 1. I'm going to use these numbers here. I believe there's 7. Okay, it should be 91. I'm going to push enter. 84, 76, 87, 91, 83, and 87. To sample 2. 71, 78, 85 and 87, 61, 72, and 66. So now that I've calculated or I've typed those in, I'm going to hit submit. And it gives me all these numbers right here. Okay, I'm going to see if I can't zoom in on this. I'm going to need these numbers here. Okay. So sample one, which was test A, that average was, we look up here, 85.571. That's that number there. The standard deviation of that was 5.2236. And the sample size they said was 7. 7 for both. My average for my second test score was down here, 74.286. And the standard deviation of my second sample was 9.5867. Okay, they gave me all that information. They actually give me a lot more information here. It says observe sample, sample 1 minus sample 2, 11.285. Isn't that what this is asking? Okay, to subtract 85.571 minus this, it should give you that 11.285. Standard deviation of the difference. So that should be this number right here. Okay, I'm going to show you again that calculation, but it's going to be that 4.1264. So that was this standard deviation. So 5.2236, and you square that number and divide it by the sample size of 7, and we're going to add that to 9.5867. Square that and divide it by 7. I know. Awesome, 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 right? Okay, that was a formula we talked about on Monday. So I'm just going to verify real quick before we get too heavy into it. It's always kind of good to verify where you can. I mean, I could take 85.571, take away the 74.286. Okay, and that'll give me that 11.285, 11.285. 5.2236, square it, divide by 7. Okay, add that to 9.5867 squared divided by 7. Okay, I'm going to square root this last answer and I get 4.1264 something. That's that answer right there. So it seems like we're doing everything on the right track. We seem like we're doing everything well. Our degrees of freedom. Okay, that is that awesome, lovely equation right here. Sounds awesome. I know, right? So that's just right here. It's going to round down to 9. Okay. It's going to be 9. And then our t-score, okay, our t-score, which it's going to be 2.7348. Okay, that they've already given us that number. Okay, that's the test statistic T. It's 2.7348. Okay, and that's calculated by saying this number, the 11.285. Okay, the difference of our means. Okay, what we found in the samples minus the difference of the means, what we thought it was going to be, which was going to be 0. Right? We thought our null hypothesis of nothing was different, right? They should go to 0. So we're going to subtract 0 and divide that by the standard error of the difference of the means. So divided by 4.1264. And when I calculate this, 11.285 minus 0 is that, divided by this, and we should get 2.7348, 2.7348. Okay? So all those values are there, okay? It's all written right there. You just got to be able to read it and understand what it's saying. When you want to find the difference of your means, that's observed difference. Sample 1 minus sample 2, 11.285. Standard deviation of the difference, this is the standard error of the difference, okay? It's the same thing for this stuff, 4.1264. Our degrees of freedom we want is 9. It says DF is 9. Our test statistic T is 2.7348. That's that number right there. And then we got to find the probability of that number. Okay, so we go to a student's t-table. What you should notice, okay, if we go to the degree of freedom of 9, okay, .7348. So I'm going to go to degree of freedom of 9 and go over until I find that t-score of 2.7348, which I don't see it, but what I do find is it's in between these numbers here. So 9, and I go over here, that 2.7 number, right, 2.7348 is in between these two numbers here, 2.262 and 2.821. So because it's between those two numbers, that means my probability is in between 0.05 and 0.02. And because it's closer to this number, it's probably closer to that number. Okay, but regardless, you can calculate it through a certain method. We're not going to do that by hand, but if you look at this, it says population 1 is not equal to population 2. The p-value is 0.182. Okay. So that's what, oh wait. They must be using some I'm looking at the equal variances. That's where that's the pool data. Like, that seems weird. So up here, I'm so sorry. So t statistic 2.7348, our p-value is 0.023. Sorry, kind of got all lost on the webpage for a moment. So the degrees of freedom is 9. We found it was between these two numbers here, 0.05 and 0.02. They're telling me that the actual calculated one with all the formulas is 0.023. So it's off by 3, so it's in between there, but it's really close to this one. Okay, it's really close to that one. So we're going to write out this number, 0.023. But I'm going to make a little note here that even if we couldn't calculate it by perfect, with this calculator, we could still estimate that this answer, okay, the probability of our t-score not equal to that 2.7, whatever, that is going to be less than, okay, it's going to be less than 0.05, but it would be greater than 0.02. So we know it's in between that interval there, between 0.02 and 0.05. We know it's between those numbers, okay? So since we know it's between those numbers, we know for a fact now that it's less than 0.05. And we know from the calculator that it's 0.023. Okay, so it's less than 0.05. And that's our general marker, like our general line, that if it crosses that 0.05, it's less than 0.05, then we make the conclusion that we can reject the null hypothesis. So we have to make our answer here, or we have to answer the question that do these scores provide convincing statistical evidence? And we're going to say that we're going to reject the null hypothesis that they're the same, and basically says that it looks like there's a difference, okay? So we're going to go ahead and write out our hypothesis, our conclusion. We're going to say there's a handful of ways we could have answered this, okay? But at the end of the day, you reject the null hypothesis that the tests have the same difficulty. Okay, we are going to reject that, meaning we're not going to accept that, and we're going to say it looks like, it appears, we believe, all those kind of words, right? We believe that the alternative is true, that there is a difference, that their averages are not, when we subtract their difference, right? When we find the difference, we subtract the averages, we get 0. We're pretty sure that's not the case. It appears like test A is just generally get higher scores, easier, or test B is harder, however you want to see it. Okay, so one more time. We found the average standard deviation sample size for each test. We subtracted those to get the difference of the test averages. We found our standard error. We found our degrees of freedom. We found our t-score. Okay, we took our students' t-score and found the probability as of it not equaling the t-score. So when it says not equal, just to give you guys a heads up, what that kind of looks like here. We've talked before about one tail and two tail, okay? And when I say this is a two tail problem, it's because it's both shaded on the left and the right. And so where this says 2.7 something, is like here, let's say a positive 2.7, we're used to like shading like to one side. Okay, for this one, when it's not equal, it's both the positive and negative, like a plus and minus of the 2.7. Okay, so it's the left side shaded and the right side shaded. That's what it means for not equal. Okay, so even by doubling our numbers, it's still on a 2 something. Okay, but we took this probability and doubled it with that probability. So what we get is still a small number. So we are for sure going to reject the null hypothesis, and we're like, they're not the same. One is simply gets higher scores than the other. Okay, and we have the evidence, we have the stats behind it. It's a small chance. Okay, it's like a 1 out of 40 chance or so that they actually are the same. Okay, small chance. The next question says the next question says find and interpret the 95% confidence interval. So going back to to our calculator, it says here confidence interval is going to be 1.9503 and 20.6197. So I'm going to go ahead and calculate it by hand just because that's kind of what we've been doing. We're going to get those answers, okay? Our confidence interval is going to be equal to the difference we found here, 11.285. And we're going to add, subtract. We're going to do two problems here. Okay, one where we add, that's the upper number. We're going to subtract, that's the lower number. Okay, and what we get is, this is usually our Z star. We're going to use our T star. This is where we go to our table. Okay, usually at 95% confidence, remember, we'd always use 1.96 for the confidence interval for our Z star. Instead, we're going to go up to a degree of freedom of 9, and I'm going to use 2.262. And then multiply that by our standard error, which was 4.1264. And what I get will be a low number and a high number, and that's basically the true average. The true average between the two tests, right? So if I did this 100 times, 1,000 times, 100,000 times, 1,000,000 times with these tests, okay. I would expect the difference between the averages to be between these numbers, okay? On the low end, this number, on the high end, that number. Okay, we're 95% confident of it. So when I calculate this, I'm going to say 11.285. And let's start with the lower number, the minus number. So minus 2.262 being multiplied by 4.1264. So this is all calculator stuff here. I get 1.95. Let's call it 11. What they have for this, it was 1.9503. So there was no rounding with theirs. So theirs was just 1.95. And then I'm going to do the add part. So 11.285 added to the 2.262 being multiplied by 4.1264. Okay. Now this calculator does use order of operations. It does do it by itself. So I get 20.6189. But if you're doing this, and some calculators kind of need you to do order of operations on your own. Okay, this calculator, you type it in left to right, and it'll do the multiplication before it adds. Okay, this calculator gives me 20.6189. Okay, round down. And when I look at the answer once again from the perfect answer where they don't round like at all and they're using better numbers, they get 20.619, 20.6197. So it's off by, what is that? Eight 10 thousandths. Okay, it's a very small difference. Very, 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 very small difference. So if you had a penny and then you cut that penny into 100 pieces, okay, as far as money value, okay, and you had 8 of those little micro pennies or whatever, right? A penny of a penny, that would be the difference, okay? 10 thousandths. Okay, take 100, cut it into 100, and it's 8 of those little small pieces. Really, really small difference. So what I'm getting at is these numbers aren't perfect, but they're very, 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 very close, especially for the work that we're doing. So we found it. Now we've got to interpret it. Okay, so how do I interpret this? I can say a lot of different things, but basically it comes down to we are 95% confident that the scores for test A, will be higher on average by, let's just call it 1.95, or you know what, by about, let's just round this up to the nearest whole number, make it pretty, okay? By about 2 to, we'll just round it up to 21, by about 2 to 21 points, okay? So we're 95% confident that the scores for test A will be higher on average by about 2 to 21 points. So whether you do this by hand, whether you do it on the calculators, the values I'm going to put up there, you should be close enough using either or, okay, to get your answers. So what I recommend doing, okay, is get very familiar with this website, okay? What I mean by that is, okay, know that if you're here, click on this 2-sample t-test DF calculator. It's going to bring up this web page. Make sure you're on the raw data, okay, because you don't know the mean and standard deviation and sample size just yet. Well, you could calculate these things, but I'm going to tell you to do it, I think, just by entering the raw data will give you the best answers. So by doing that, okay, sample 1, 91, 84, 76, 87, 91, 83, 87. Sample 2, 71, 78, 85, 87, 61, 72, and 66. Okay, hit submit. And it's going to give me all these answers. Okay, one more time. My sample 1 average is 85.571. Where'd it go? Standard deviation was 5.2236. Standard error, we don't even need that number. Our sample size was 7. Okay. Our sample size for B, sorry, sample average for B, 74 something. Standard deviation 9.5 something with a sample size of 7. Our difference of our average 11.285. Standard deviation of the difference, or we're using the standard error of the difference, we get 4.1264. Degrees of freedom is 9. Find our t-score of 2.7348. So we know it's far from the average. It's almost 3 standard deviations away from the average, or 3 standard errors away from the average. That's going to give us a probability. When we go to our t-table, we find it between 0.02 and 0.05. Okay, that 2.7 number is in between here on the 9 degrees of freedom. So we know it's between those numbers. Specifically on this calculator, they tell us that it's they tell us that it's 0.023. Okay, and that is population 1 is not equal to population 2, right? That's what we're testing against. Not less than, not greater than, but just simply not equal to 0.023. Okay, so we know that's the perfect answer, but even if we didn't know that, we could still kind of deduce that it's between those two numbers. So that's got to be the only option, okay, if it's a multiple choice. Those numbers down there we don't need. All right, and then it says to find, so make a decision. We reject the null hypothesis because this number is less than 0.05. Remember, we want this number here to be less than 0.05. If it is, we reject the null hypothesis. If it's 0.05 and higher, we fail to reject. Okay, we don't reject. We kind of say, well, they might be the same. We don't know yet. We need more information. Okay, that's usually the general answer. Question 2, find and interpret 95% confidence interval. So I found it to be between there, which I could have just did this and said 95% confidence interval for the difference, 1.9503, 20.6197, which I found numbers that were extremely close to it by doing it by hand, okay, with rounding there. All right, so I rounded and I got those numbers there. And so I went ahead and rounded it again and said, well, that's going to be like 2. I'll bet 21. So we're 95% confident the scores for test A will be higher on average by about 2 to 21 points. Okay. So if you had all the tests for test A, all the tests for test B, okay, and scored them and found the average, it probably isn't going to be 11.285 like we found in this. It might be anywhere from 2 to 21. Might be higher, might be lower. We don't know, but we're pretty much sure, almost 100%, we're 95% confident that test A will just always have a higher average, somewhere between those points. Okay, so that's convincing enough that they're not the same difficulty. Okay, so I will leave this alone where it's at. I will be posting this video online so you guys can review for your test, your quiz.